long time, actually.
Okay. Thank you, Bill, for your introduction. It's my pleasure to present what I did before. The title I will present is Where's Hybrid Soybean and Progress and Challenges. Can you hear me well? Okay.
Good.
So why I choose this topic? As Bill mentioned, I work for Zhanyou right now, and I'm working on bioinformatics and computational biology. I did some work but need additional data validation, so I won't present what I'm doing now. Instead, I will present the one I worked before, and also I still continually monitoring the hybrid soybean, which is one of my major interest part. So if you have worked on corn breeding, well, you may be familiar with these slides. There's two slope. This is over 150 years yield genetic gain for corn breeding. There are the two slope. One of those is the yield genetic gain through double cross, and the other one is the yield genetic gain through single cross. You can see the angle of slope is different. The single cross is bigger than the double cross. And then when you compare the four major crops, maize breeder can be very proud to say we made huge progress as a yield genetic gain. Congratulations. And second one, the rest is follow the maize has huge genetic gain. And third is the weight. And then the last one is the one I work. I'm passionate on it, but I realized we have a lot, our genetic gain, yield genetic gain is not that huge as maize. Instead, the soybean genetic gain rate is decreased. When you see like 1910, the yield is about 15 bushels per acre. The genetic gain is 1/3 bushel per acre. And still by now, still 1/3 per acre, but the yield genetic gain compared with about 50 bushels per acre, your genetic gain rate actually is decreased continually. And then what is the reason behind it? So the conclusion is there's no hybrid soybean. And if you compare this figure, come back to see this figure, maize hybrids, heterosis, rice heterosis, weight, the expected commercial hybrid weight will be 2019 or 2020. So heterosis in weight will be available. Right now, the four major crop, soybean is the only one has not have commercial hybrid soybean yet. Then that's come to the topic of my topic. Where is hybrid soybean? What is the progress? What is challenge? So through my presentation, I will answer three questions. One is how many soybean cytoplasmic male stereo lines are developed. Here I focus on CMS, not nucleotide. A lot of people know in our Iowa State University, Dr. Reed Palmer he worked on the nuclear male stereo gene. Male stereo line tried to develop hybrid soybean. So my presentation focused on the CMS line only. So second question is, what is the magnitude of heterosis? We know there is heterosis, but we want how big or what's the magnitude? The last question is, there's no hybrid soybean. Where it is, can we produce commercial scale hybrid seeds? So that's the three questions. I go over. This is the first one. Start with patents. You can see from the year hybrid soybeans relatively new. The first patents was in 1985 from USA, and the last one, what I can check from the Google patent.com, the last one I see is hybrid soybean is Harry Stan. They use the Roundup Ready to kill the fertile plants, but that is the last one to produce hybrid soybean. And from China, the first one is 1993. And the difference between the 1985, that one is from cultivated soybean crossed with cultivated soybean. The one they found in China in 93, that is the first one between glycine max and glycine soda. And after that, there are several patents follow those. And the one I worked, the group I worked is this one. We developed also CMS, and we map some of those restorer genes and screen out male sterile, cytoplasmic male sterile donors. So that's the patents so far. You can see there are not many patents related to those compared to other crops. And then the following is the work I did, or my group did, when I was a breeder. So we know we search those patents, and then we start to screen the germplasm. Since I work in National Gene Bank of China, we want to find the cytoplasmic male sterile donor. Then we start to do the reciprocal crosses. So as you know, in order to prove that cytoplasm contains the cytoplasmic male sterile gene, we need to do the cross. Here I use P1, P2, and P6 as an example. So we have P1, P2, both are fertile. When you cross P2 cross P1, they are fertile, but when you use P1 as a female, it's sterile, then this process proves P1 contains the cytoplasmic male sterile gene. And in order to prove this cytoplasmic is not only work in this specific background, we make cross with other germplasms. This is one of the germplasm we made is P6. When you make a P6 as a female, you can see they have a lot of pods. It's fertile. But again, when you use P1 as the female, then it's sterile. Then this confirms the cytoplasm coming from P1 it contains the cytoplasmic male sterile gene and also work across different germplasm. We did many, here just one example. That cytoplasm work across different genetic background. So the results is we searched hundreds of lines at that time across different institutes. We found two germplasms that contain totally different cytoplasmic donor. And as you may know, this is really, really hard to find a unique cytoplasm donor for the CMS line development. Those two lines was used as crossing parents widely. And those results we did using, we need to check whether the sterile lines is a partial sterile line or fully sterile line, because 5% fertile pollen will have enough pollen to pollinate. So we need fully sterile. In order to do that, we check the pollen. Those are the pollen for sterile line, and this is restorer line. This is the hybrid line. You can see those from the hybrids or the restorer line, the pollen stands very well. We also developed a marker at that time, and we mapped the restorer genes. And the most important is we use this marker to screen our germplasm because you cannot make so many crosses. We have to use a marker to find the line that contains this restorer gene, and then we make the crosses. So, so this is a summary to answer the first question. How many CMS lines have been developed so far? If you check the year from 1985 to 2006, there are not many. I didn't find any after 2006. When I read those, I found over 90 CMS lines have been developed. So here there are two I want to point it out. The first one is Reed Palmer. In 2001, they developed a line using the cytoplasmic donor, which is same as the one we identified. And this line is a PI line from China, National Gene Bank. The other is the one my group developed in 1999. So from this summary, we can draw the conclusion it's not difficult to develop CMS line. So we have many CMS line for hybrid production. And that's the first question I asked. Any questions before I move to the second question? No? Either because I presented very well or maybe because I didn't explain well. Please ask if you have any questions. So second question, what is the magnitude of heterosis? So here the summary table, and from the heterosis studies earlier than the CMS line developments, from 1970 to 2050, the last paper is last year, and the heterosis range from negative 50% to 90%, and the average to 20%. That is the take-home message. There is heterosis, it's about 20%. Please remember that number. And then you will ask those numbers, is this coming from large number of populations or from one or two populations? Here to give you the answer. So there are two numbers I want you to pay attention. One is Dr. Burton, and he made 275 populations. The average high parents heterosis is 20%. And the other number is 1,326. This is the one in China. I will go details slides from next one. So the 20% heterosis not coming from several smaller number of population, come from over 1,000. So far, this is the largest effort had made to test and to estimate heterosis and how big the heterosis. So those 13,000 combinations, the hybrid was planted in 7 provinces in China, and they are very diverse environment. And then the second year, we plant the best 176, which has higher heterosis. We check how much better compare with the high parents heterosis, and also check with the best local checks. And then we found out the combinations that is better than the high parents heterosis and also the checks. And the total number of lines combination we found is 39. That is better, 120% better than the checks and also the high parents. So you can see it's easy, not difficult to see. There is heterosis and also average 20%. And then how can we produce commercial scale hybrid seed? So that's the most difficult part. So these slides show the nationwide project that try to find the best location, to select the location for the seed production. Here, this is northern China, central China, and southern China. You can see here the tropical trees here. And again, our target is to find optimal humidity and the temperature, and also that there's less rainfall for bee. Again, inside those nest tent, we put the bees, use the bee to pollinate. So this slide is the real hybrid seed production field. You can see here we have 2 rows of A line, and then we have the restorer line. And the bottom 2 figures show how big the heterosis, what is the F1 plants looks like. This is hybrid soybean 1, this is hybrid soybean 2. Those already patent combination in China. So here the summary of the heterosis. You see pictures, here are those numbers. And if you're familiar with soybean breeding, you see those numbers, you feel maybe a pity. So how low yield these are, like less than 10 bushels this one. But remember, those are hybrid seeds pollinated by bee in the field. So this is the one I highlighted because this is the one my group did. The hybrid seed production yield is only 8.5 bushel per acre, but the heterosis is 55 bushel per acre. It's better than the local check 120%. And here another number is the highest yield for the hybrid seed is about 15 bushels per acre. It is still very, very low. So you can see, compare with currently here in US, it is 55 bushel or 65 bushel per acre soybean is very, very popular. And in order to reach the 50 bushel or 60 bushel per acre, there's a long way to go. So what is the challenges we face, and can we overcome those challenges and to produce a large-scale hybrid seed? First one is soybean is cleistogamous. That means the flower already pollinated before it's open. You can see the pollen will already transfer to the stigma before the flower is open. It's really hard for the foreign pollen to pollinate the female. That's the first challenge. The second one is soybean pollen is heavy and sticky. Is entomogamy, the pollen transported by the bee. And also when the flower is attractive to bee, actually the flower already pollinated. So that means when the bee visits that flower, it cannot transport, the pollen cannot be used for that flower. It only uses the neighbor flower which not pollinated yet. So that's another level of challenge to pollinate soybean. Number 3 is the natural hybrids. You can see this is a soybean production field, and this is the one plant is a hybrid because you can see those are single poles, and this is zoom in for this part. You can see even though it's a real hybrid, the yield is really low. Usually they have only 1 or 2 seeds per pulse. And if you have ever pollinated, you can see there are very few 3 seeds per pod if you manually pollinate it. So that's my experience when I'm manually pollinated in China and Illinois. So we have challenges, but also we have opportunities. So here the 2 opportunities is there's a soybean mutant. It has, first thing, it has 2 characters. One, it is exerted. Usually the stigma is inside the flower before it's open is already pollinated. This one is exerted. And second one, this is 2 stigma. Usually 1 soybean flowers or 1 stigma. So with this mutant, it has 2 exerted stigma. And people try to make crosses and transfer the 2 exerted stigma to the male sterile line. If that becoming true, it will increase the chance to for the stigma accept foreign pollen to increase the cross-pollination. And the second one is a recent papers, 2010. They cloned the cleistogamous gene. So here, they cloned the gene that controls the lodicle, and they use mRNA to silence or to activate the genes that make the lodicle bigger, and compare with this one, to silence the gene. And then they push the flower open. They'll make it from cleistogamous and cannot accept foreign pollen to make it open and easy to accept foreign pollen. So that's the big good news for soybean world. Soybean scientists try to use the same gene, use the GM to produce the non-cleistogamous flower. It's hard, but still, some scientists are working on that. So that is the challenges, that opportunity we have. To summarize what I presented, first one is how many lines, CMS lines, we over 90 CMS lines developed, and the sterile is stable across US and China. Dr. Palmer and the Chinese scientists, they test the stability across In China and the US, they confirmed the one that is stable. And the heterosis is about 20% across over 1,000 populations. And the heterosis is significant. And the third question is produce a commercial line. We have a long way to go. And currently production only 12 to 15 bushels per acre. So, but we have the opportunity to increase the cross-pollination. That's my presentation. And any questions? Yes. Yeah.
Do you think that the genetic background in the soybeans when doing the crosses has anything to do with the number of seeds per pods? I pollinated numerous soybeans, and depending on what combinations I'm creating, I've seen 3-seeded, and I've seen quite a few on some. I've seen 2, and then it also depends on some other factors.
Yeah.
Do you think that has anything to do with it?
Let me repeat the question she asked. I presented usually the manually pollinated hybrid has 1 to 2 seed per pod, and Haley asked is there different genetic background effects? Some crosses may have 3 seeds, hybrid seeds per pod. I will say yes. Some population they may have 3 seeds or 4 seeds. But my experience is when we go to the field, the first impression we say if it's a 1 seed per pod, and we say, oh, that is a real hybrid. If we see 3 seeds or 4 seeds, we will have a question mark in our mind. Say, this is a real hybrid, or will you pollinate already? Will you manually pollinate? Actually, it's already pollinated. So. Yes, lady first.
Thank you, Zhanyou, for your presentation. So my question is more about what efforts have been made in order to improve the pollinators. They have done any other studies between different insects, maybe, or different species. I don't know if you can say something.
Yeah, the question is what effort have been made for the pollinator. Yes, there are many efforts, including Dr. Palmer. He tried to increase the nectar contents. If the nectar is a higher quality, like sugar or sand, then that will increase the cross-pollination. That's one effort. And the second effort is my group did. We actually go to the field. We have the honey. We know this coming from the bee. And then we make a honey solution, spray to the flower. Then we saw may increase the cross-pollination because that is a product from the bee. The bee should love it. And also we have there are at least 3 different species of bee. One's honeybee, mango bee. I forgot the third name. We introduced different bee species from USA, Europe. Since Europe, they pay a lot of attention to the bees for other vegetables. So we introduced 3 different bee species and compared the seed side and the pod side. And we found out that the one is not like nice bee, gentle bee. Is a mango bee is very aggressive. They compete with the other bee, try to kill other bee, and to pollinate. So that's the work my group did. Yeah.
Thank you for sharing.
Yeah. Yes, please.
One of the questions I have is, when you're looking at these male sterile lines, can you comment about maturity? Is the maturity later? Because I saw in that one picture that you had this green plant and everything was out, and everything else was senescent.
Yeah. So the question is hybrid soybean and the relative maturity. Yes. So the one I show You can see others already mature, and this one still green. That's very, very true because the sterile plants, they have full of energy, like young children, they full of energy, but they haven't used the energy to produce the seed yet. So they, they are the one still very, very green, and actually the troublemaker for the combine. Yes. Please.
Hello. So since we're doing hybrid, have you looked into the soybean hybrid group and see if there's actually well-defined clusters where you can make predictive crosses to produce really good hybrid?
So the question is, since we try to produce hybrid, have we tried to find a heterotic group in soybean? We did that effort, not from previous study. It's once I joined Syngenta. One of the work is our Syngenta makes thousands of combinations. We don't test F1 yield because we only have 10 or 12 seeds, so there are no yield test. Then our global head asked us, is that possible? Use F2 seeds since you have more seeds to do the test to find a heterotic group. We have very, very limited efforts, and because from business side, they didn't see it in the near future will be coming commercial. So there are very, very few efforts on that, but it's a very good question. People still asking whether they have a heterotic group in soybean, just like in corn. Then when we make a cross, like we make thousands of cross from Syngenta, then you just make the cross between heterotic group, not make the cross within that group, increase the opportunity to produce a superior progenies. Yes. John, you have a question.
I mean, my question was along the lines of Beth's question. I was really
Okay.
interested in the pollinator
Okay.
thing about it. But what about the other way? What about selection on bees that favor those flowers, soybean flowers? Working with an entomologist or something like that. I don't even know if there's insect breeders. I don't know if that exists. but it'd be an interesting thing to consider.
Yeah, the question is, in order to change the soybean from find the exerted stigma or whatever the non-clistogamous, your question is whether we can start from the other side to breed for specific bees that pollinate soybean only. Yeah, that's a good question and a good idea. And I know some people work on those, but I didn't track that. I didn't find any people specifically work for soybean because, like soybean, to me is like I like fish, don't like chicken. For the bee, maybe that is the rose flower is their fish, and then chicken their second level of food. So if they have the choices, the rose flower is beautiful, is a lot of nectar, they will go to rose flower. They will.
Yeah, or even breeding a colony or colonies of bees just around soybean flowers.
Yeah,
And
that's
propagate them.
good idea.
Interesting field, too.
Yeah, good idea. Please.
So in your opinion, do you think that the reason why soybean hybrid seed production hasn't taken off commercially is because there's still too many challenges to make it logistically possible? Or do you think that there's not enough heterosis to make them feel interested?
The question is we don't have commercial hybrid soybeans because we cannot produce enough seeds or because of low heterosis. So the answer to me is clear. We have the heterosis, about 20%, and easy to find those. The big challenge is to produce big enough hybrid seed. As you can see, there are huge amount. I will say millions of US dollar or billions of Chinese dollars invested, try to increase the hybrid seed production. Right now, the highest is 15 bushels per acre. And they have a calculation. In order to make the commercial, you have to reach to maybe 20 or 25 or 30 bushels per acre. Because farmer buy the hybrid seeds, they will pay more and the 20% will now cover that seed cost. So they have a formula, but I don't have that formula. I know some people calculate. So if you reach like 25 bushel per acre, maybe it can be commercial. Yeah. Yes.
How is the seed quality for these successful crosses vetted?
Can you speak more about your question?
Have you tested like vigor or germination?
So
Are they big seeds or small seeds?
So the question is, have we test like the germination or seed size of the hybrids? So to generally say the F1 has a heterosis, we will have a better germination, and also it has a better germination. I know that, but the seed size, I'm not sure. Whether the hybrid has a bigger seed size or not, I don't know the answer. Yeah, please.
Yeah, and that leads to my question. What is the yield increase mechanism in terms of yield components? Is it more pods per plant? And if so, what happens when you have a higher plant density? Is that greater number of pods per plant still expressed?
So the question is, what is the mechanism hybrid seeds has higher yield? And that's a very good question and also challenging question. I will guess if it's a hybrid, from the beginning it will have higher germination, higher defense disease resistance, or abiotic defense is better than the two parents. And also in later generation, they have bigger plants. It may be a combination of many factors, but I really don't know. And from my side at that time, I just want to, I know some people study for that. It's a really good question. I don't know the answer.
All right, on that note, fantastic questions. I appreciate the audience participation today. Very good. So, Zhanyou, thank you very much for your presentation.
Thank you.